Pearl Harbor was being burnt, and the world was at war in 1941. However, there was another crisis that was taking place outside the battlefield. The soldiers had to stay in tents that in tropical storms collapsed and did not provide any respite to the harsh heat of the jungle. The American Army required an innovative type of shelter, one that was tough, fast to construct, and dependable under any circumstance. This was an impossible task that was undertaken in 1942 by a group of American engineers. The world has not been the same in terms of construction of shelters because of what they made. This is the story of courage. It is the history of the Quonset huts. But how then do you suppose they could construct shelters to withstand fierce storms, attacks by enemies, and fierce heat in the jungle? The U.S. military found itself in the middle of a severe and desperate logistical crisis after the crippling attack on Pearl Harbor. The Pacific Front was not kind moving as far as remote islands where the soldiers of America fought with the enemy and with nature. Hundreds of soldiers were camped in wet, improvised tents in whose rain the tropical rain never appeared to end. Their canvas tents were drowning in the rain, and every joint was filled with water and collapsing under the powerful winds. Their shelters were constantly wet. Their uniforms and stores were no exception. Rations were spoiled, ammunition corroded, and necessary equipment was useless. Under such circumstances, pneumonia and other diseases are transmitted at an alarming rate, and millions of men appeared on the hospital bed when they were the most necessary on the battlefield. The realization that this could not be sustained in the military was soon to come. There was no chance of constructing strong wooden barracks, which was the common method. The Pacific distances meant that lumber was almost impossible to transport, and even the number of building material demanded in the home country was overwhelming because of the war effort. Time was a luxury, also, which they lacked. The soldiers required proper weatherproof buildings that could be put up in a short period, withstand the tropical storms, and safeguard them against the diseases. What was required was innovativeness, a new, efficient, durable way of doing things to keep the American forces alive and in operation in the very dangerous Pacific theater. Something better is wanted, fast. Of the perfect military shelter, they find their search in the British Nissan huts, curved, steel-framed buildings which were introduced in the World War I. These shelters had since been of good service in the battlefield. They were very powerful and reliable and capable of enduring severe sandstorms and holding many soldiers. Better still, they could be put together without necessarily involving the high-skilled labor, and hence they are viable as a consideration to fast deployment in remote or unstable areas. But Nissan huts were not so great. Although rugged, they had a number of disadvantages that rendered them to be not applicable in all the environments. Their bodies were made of steel, which was quite strong but very heavy, and could not be easily carried across different continents, or even over rugged terrain. They insisted on having solid foundations to support them, which consumed more time and resources to construct. These metal shells became stuffy in hot climates where they held the heat and were intolerable under the tropical weather. Having these shortcomings in place, the American engineers were in a very dire situation, which is, how can they come up with a shelter that is lightweight, fast to set up, and strong enough to withstand the most extreme weather that is ever to exist upon the earth? The specifications that are suggested are nearly unrealistic by themselves. On the one hand, creating a structure which is lighter than a Jeep can be assembled with the help of virtually anyone, but is stronger than any conventional tent goes against common sense. To add to that, it should be small and strong enough to be transmitted and set up at any part of the world with the least effort. Such an obstacle stretches the limits of what the currently accepted engineering paradigm believes is feasible, requiring a radical reevaluation of materials, design procedures, and building practices. When the engineers meet in Rhode Island to set about solving this grandiose task, one soon realizes that the conventional concepts of architecture and structural design will not pass the test. Standard rules, codes, and standard techniques start to curb one as opposed to being a guideline. They must think differently and act quickly. Perhaps they should even take the chance of ideas most professionals would not succeed with. An engineer, Otto Brandenberger, comes out with an idea, which is an unconventional one. After decades of experiment and failure, he suggests something gallant, a thoroughly new design of shelters. His team would use a technology of building a structure entirely of steel instead of the old wooden frame, which was a limiting factor in terms of strength and durability. The vision of Otto is to reconsider all of the elements starting with the foundation, and not only about functionality, but also about resilience and versatility. The notching of wood is a risky step, yet it is based on the knowledge that to continue, they are required to leave their past behind, which is no longer of use. The outstanding feature of the design is the purulent arch form. The arch, far otherwise a flower of aesthetic taste, has an important structural end. It has an inherent ability of repelling heavy winds, drains away rain, and is stable without depending on costly internal supports. All the tests that were experienced in the earlier designs are lessons which became part of this new design. Every failure of the team will pinpoint the areas where the team is flawed and use it to innovate itself. They never rest even at night, revising, testing, and adjusting each other along the way. This is opposed to the previous projects that were confined to blueprints and models. This one develops using real materials, concrete development, and practical experimentation. As the project progresses, the team completes a semicircular arch composed of interlocking steel panels. This arrangement makes the construction smooth, and every panel supports the next until it becomes one. It is the simplicity of the shape which is the genius of it. It dispenses the force evenly and enables the shelter to withstand the strongest winds, the most incessant rain shower. The arch does not give in to the pressure even in harsh weather. To Otto and his group, it is not merely about construction of a building, but it is about reinventing how fast and effectively a reliable structure could be erected. Their eventual aim is quite obvious: to design a design which can be assembled in hours instead of weeks, one which will stand firm regardless of what the elements may hurl its way. This is when the stake grows higher, since the success of these huts is at stake. In case their structural design collapses in the middle of an intense storm or in the influence of a bombing, the number of lives lost is enormous. To ensure that does not occur, engineers carry out unending tests in the field. They subject the huts to wind tunnel tests, heavy storms, and even mock bombings, so as to determine their ability to handle and survive a lot of pressure and destruction. Each test turns out to be a decisive factor of the capability of design to act at the most unfavorable circumstances. Trying to find some certainty, the engineers take one of the huts to the Panama Canal zone, where the air is dense and wet, and the weather merciless. Once again, the building is put to the test there, under harsh tropical weather. The findings are amazing. Design is strong and reliable. And when the initial huts have taken their toll in the Pacific, in weathering the bomb explosions and the fury of the typhoons, the gamble of the engineers becomes successful. In a few days, factories have developed into places of unremitting movement, round-the-clock production of thousands of compact huts per month. These are efficient structures. Each structure can be packed flat to conserve space and transported in a short time span over extensive distances. As soon as they arrive at the place, a small team of workers who have only the simplest equipment can assemble them within a small time frame, making what used to be a deserted section of the land a working shelter area. With an increase in production scale, cost reduces and speed replaces speed. What comes out is a spectacular change in the war-torn terrain. The soldiers deployed in high-risk areas have been enjoying reliable areas to rest, strategize, and work, the first time ever after months. In the heat of the blister, in the freeze of the rain, or even in hearing range of the front, these huts hold their own and offer such a security and permanency of being as had appeared to be impractical in the battle. Field reports keep on coming all around the world, and they are all about the amazing tenacity the Quonset huts had amidst the severest conditions one can imagine. These steel constructions are curved and shaky in falling of bombs, but they do not collapse, and their design is so simple and powerful. When typhoons blow over distant islands with screaming winds and pouring rain, the huts stand firm, and the only refuge and protection are there when very little more might be spared. Their fortitude is everywhere, on battlefields and in remote posts far away, and is a symbol of expediency and confidence in design. Special alterations are made in the frigid Alaska climatic conditions to resist freezing of temperatures. The huts are resistant to the unstopping frost provided by extra insulation, improved joint sealing and heating solutions. At the same time, in the damp climate of the Amazon, soldiers create new ventilation systems and ingenious cooling techniques that transform these metal shells into wonderfully habitable places. Every challenge is followed by a new innovation, and every solution is promptly relayed to the headquarters. The result of this constant interchange is that each subsequent variant of the hut is more vigorous, intelligent, and efficient than its predecessor, a living demonstration of human adaptability and the quick educational process that necessity necessitates. With the World War going on in full blast and the demand of quick and dependable housing at all times and rates, American industries were answering the call with unsurpassed speed and effectiveness. During the war years, the factories in the United States worked 24 hours manufacturing the materials and labor into mass production lines of Quonset huts. These were light, semi-cylindrical structures, and these became the emblem of ingenuity in war. And in a few years, it is estimated that between 150,000 to 170,000 of these structures were rolled on assembly lines. It was so efficient that what previously appeared to be an enormous task was quickly made a routine affair, as each new delivery was taken to remote fronts where makeshift buildings were crucial to operations and the welfare of their troops. These huts were soon dispersed almost everywhere on the globe war theater. On the distant palm-lined Pacific islands and on the rugged European fields, Quonset huts were sprouting everywhere the military required fast and durable space. They could be erected in hours, making use of land that otherwise would go to waste into military installations. Entire encampments, hospitals, headquarters, and storerooms almost appeared overnight, and this was all held together by this simple yet metamorphic design that was so practical and so adaptive at the same time. The lowly Quonset hut had already shed military origins by the time the war was over. The steel shelters had plenty of future life in the peacetime America of America, when so many of them were left unused after the conflict. Societies reused them into schools, diners, churches, workshops, and even family houses. The geographical features of the post-war America were marked by the visible reminders of this period, because the silvery shape of the Quonset served as a permanent reminder of the industrial ingenuity, the need of the war, and the spirit of the American that was always ready to renovate itself. Although Quonset huts were designed to be wonderful and admired by many, they were not perfect. As time passed on, the soldiers and the families residing in them started noticing that the very rounded nature which provided such huts with their unbelievable stability also posed certain practical issues. Curved walls had a strength but were unique, which meant that organizing usual furniture was hard, and there was no opportunity to add more partition walls so that the space could be tailored. When there was a downpour, the drumming of the droplets on the metal shell would reverberate in the interior, producing a booming sound, which could be deafening. Telephone conversations could only be made louder, and when listening to the radio or watching television, it was normal to increase the volume to the maximum. Both engineers and homeowners struggled with the traditional insulation problem, and their own solutions were developed to fight the tropical heat or frozen winter snow, depending on the area. The logistical hurdles, besides comfort, were also present. Modifications to Quonset huts to fit the current requirements difficult to modify, such as heating and cooling, or with the traditional windows and doors, usually required specialized equipment and increased cost. Local building codes, zoning regulations, and homeowners associations opposed their use in most neighborhoods because of their industrial look, which was inconsistent with traditional architectural designs. Although durable and simple to put up, Quonsets had little privacy in the open-plan interiors, and all may not have liked the brightness of the corrugated steel exterior that made up their appearance. What came to be regarded as a wartime invention and a post-war emblem of usefulness by certain individuals was seen by them as a design that had a sensible amount of utility unbalanced with an inconvenience of some degree. The Quonset hut story did not end with the triumphant victory parades at the end of the war. Actually, its tradition lived on many years after the guns were silent. When the soldiers were coming back home and cities across the country were struggling with a colossal housing crisis, millions of veterans were ready to begin anew, create families, find employment, secure peace. But there were not enough houses to meet the demand. The pressure was immense, and communities had little time to waste. Traditional building methods failed to keep pace. In order to find a viable short-term solution, people turned to what they already had: spare Quonset huts, those simple curved steel constructions built for military efficiency. During that desperate yet innovative post-war era, these huts found a second life. All across America, from the overpopulated regions of Brooklyn to the spread of Los Angeles, they were reused as temporary schoolrooms and dormitories. Veterans, their families, as well as students, transformed these utilitarian shells into habitable and homely spaces, though they had never been intended as permanent residences. Remarkably, many of these buildings outlasted their expected lifespans and stood for decades as symbols of adaptability and resilience. They became silent reminders of how ordinary citizens, facing the hardships left in the war's wake, could transform instruments of conflict into homes of peace and renewal. The next time that you look at a curved steel structure, just stop and consider what might be the story behind it. What may look like a simple building once stood as a symbol of ingenuity in times of crisis. The Quonset hut, made in a kind of hurry and shaken in tempest, conflict, and fire, was made a refuge of many thousands. It helps us to remember that boundaries can be overcome when creativity collides with collaboration. Since it has a tiny beginning and far-reaching influences, its legacy is the evidence of the fact that the strength usually is enough to produce the simplest designs and the boldest of ideas. If you learned something new from this video, consider subscribing to the channel and giving it a like. It really helps and means a lot.